Okay, chapter 1. Learning objectives. Define and describe the scientific method. Summarize the characteristics of the scientific hypothesis. Develop a scientific hypothesis. Explain the importance of communicating results. How do scientists obtain new knowledge? All the information in textbooks had to come from somewhere. In the sciences, that's probably what it says. New information about the natural world is a result of the scientific investigations. These investigations are shaped by the scientific method. The scientific method. The scientific method is a process used to investigate the unknown, figure whatever. It is the general process of the scientific investigation. This process uses evidence and testing. Scientists use the scientific method so they can find information. A common method also allows all scientists to answer questions in a similar way. Scientists who use this method can reproduce another scientist's experiments. Almost all versions of the scientific method include the following steps. Although some scientists do use slight variations, number 1 is make observations. Oh, I did not get the Maven right. Number 2 is identify a question you would like to Identify a question you would like to answer based on the observation. Number 3, find out what is already known about your observation, research. Form a hypothesis, test the hypothesis, that's my favorite part. Analyze your results and draw conclusions. Communicate your results. Making observations. Imagine that you are a scientist. While collecting water samples at a local pond, you notice a frog with 5 legs instead of 4. Ew. As you start to look around, you discover that many of the frogs have extra limbs, extra eyes, or no eyes. One frog even has limbs coming out of its mouth. Oh, gross. These are observations or things you notice about an environment using your 5 senses. Okay. The next step is to ask a question about the frogs. You may ask, why are so many frogs deformed? Or is there something in their environment causing these defects, like water pollution? Yet you do not know if this large number of deformities is normal for frogs. What if many of the frogs found in ponds and all lakes all over the world have similar deformities? Before you look for causes, you need to find out the number and kind of deformities that is unusual. So besides finding out why the frogs are deformed, you should also ask, is the percentage of deformed frogs in this pond greater than the percentage of deformed frogs in other places? Research existing knowledge about the topic. No matter what you observe, you need to find out what is already known about your questions. For example, is anyone else doing research on deformed frogs? If yes, what did they find out? Do you think that they should repeat their research to see if it can be duplicated? During your research, you might learn something that convinces you to change or refine your question. From this, you will construct your hypothesis. Construct a hypothesis. A hypothesis is a produced explanation that tries to explain an observation. Wow, okay. A good hypothesis allows you to make more predictions. For example, you might hypothesize that a pesticide from a nearby farm is running into the pond and causing frogs to have extra legs. If that's true, then you can predict that the water in a pond of non-deformed frogs will have lowered the levels of that pesticide. That's a prediction. You can test by measuring the pesticide levels in 2 sets of ponds. Those with deformed frogs and those with nothing but healthy frogs. Every hypothesis needs to be written in a way that it can. Number 1, be tested using experiments to collect evidence. Number 2, be proven wrong. Number 3, provide measurable results. Number 4, provide a yes or no answers. For example, do you think that the following hypothesis meets the 4 criteria above? Let's see. Hypothesis. The number of deformed frogs in 5 ponds that are polluted with chemical X is higher than the number of deformed frogs. Okay, I'm just going to read over the hypothesis again. You can edit that out. The number of deformed frogs in 5 ponds that are polluted with the chemical X is higher than the number of deformed frogs in 5 ponds without chemical X. Of course, next you will have to test your hypothesis. Like I said, my favorite part. Okay, test your hypothesis. To test the hypothesis, an experiment would be done. You would count the healthy and deformed frogs and measure the amount of chemical X in all the ponds. The hypothesis will be either true or false. Doing an experiment will test most hypotheses. The experiment may generate evidence in support of the hypothesis. The experiment may also generate evidence providing the hypothesis false. Once you collect your data, it needs to be analyzed. Analyze data and draw a conclusion. If a hypothesis and experiment are well designed, the experiment will produce results that you can measure, collect, and analyze. The analyst, fancy word, should tell you that if the hypothesis is true or false. Refer to the table for the experimental results. Table I don't have to talk about. That's good. Your results show that pesticide levels in 2 sets of the ponds are different, but the average number of deformed frogs is almost the same. Your results demonstrate that your hypothesis is false. This situation may be more complicated than you thought. This gives you new information that will help you decide what to do next. Even if the results support your hypothesis, you will probably ask a new question to try to better understand what is happening to the frogs and why. Drawing conclusions and communicating results. If a hypothesis and experiment are well designed, the results will indicate whether your hypothesis is true or false. If a hypothesis is true, scientists will often continue testing the hypothesis in new ways to learn more. If a hypothesis is false, the results may be used to come up and tested with a new hypothesis. A scientist will then communicate the results to the scientific community. This will allow others to review the information and extend the studies. The scientific community can also use the information for related studies. Scientists communicate their results in a number of ways. For example, they may talk in small groups of scientists that give talks at large scientific meetings. They will also write articles for scientific journals. Their findings may also be communicated to journals. If you conclude that frogs are deformed due to pesticide not previously measured, you would publish an article and give talks about your research. Your conclusion would eventually help find solutions to this problem.